Today, I'm going to be discussing gravitational waves in video games, specifically how video games like Minecraft can be used to simulate more complex systems. What are gravitational waves? Gravitational waves are essentially just ripples or disturbances in the fabric of space-time caused by giant masses. These objects are usually on the order of solar masses, so multiple times the mass of our Sun. Gravity waves release an absurd amount of energy, radiating out as incredibly tiny waves. The events that finally led gravity waves to being detected was a binary system of two supermassive black holes that collided. When they did, they released 50 times the amount of energy from every star in the observable universe combined, and converted about 3 solar masses into pure gravitational energy. Gravity waves were first proposed by Henri Poincaré in 1905. Einstein later made a few revisions and additions after being skeptical himself that gravity waves even existed, wanting not to include them in his work. It turns out that it was Einstein's assistant that convinced him to revisit gravity waves, and he eventually republished his work. In the 1950s, work shifted from explaining and detecting waves to seeing if it was possible to harness them for energy. The sticky bead argument was proposed by Richard Feynman. The main premise of the thought experiment is that if gravity waves pass over a rod with two beads on it and can cause the beads to move and oscillate, causing friction and heat, the waves must be doing some kind of work. Weber later attempted to measure gravity waves directly and claimed that he did, however it was never verified. Weber's bar was a huge aluminum bar with a known frequency whose length was measured to find gravity waves. However, his results weren't ever figured out. There was also work done indirectly to detect gravity waves. Hulse and Taylor Jr. found evidence of energy loss due to gravitational waves in a binary pulsar system. They solved the pulsar system for over a decade, and the energy losses due to gravitational radiation were consistent with what would be predicted using general relativity. Finally, Rainer Weiss and Robert L. Forward made the first prototypes of the laser interferometer, which would eventually be what detected the gravity waves. The first version of LIGO, or the Laser Interferometer Gravitational Wave Observatory, was made in the early 2000s. It first went online in 2002 and stayed online until 2015. In 2015, LIGO finished upgrades and had the advanced LIGO, which was 4 times more sensitive. It made the first direct detection of gravity waves on September 14, 2015. Since then, it has made at least 4 more detections from merging black holes. There are a few main ways to detect gravitational waves. Interferometry, which has been the most recent and best way so far. It involves splitting a laser beam in two and sending them orthogonal to each other down a certain distance that's known, then reflecting them back and comparing them. When gravity waves pass through one of the arms of the interferometer, it will stretch or shrink the light and cause interference at the comparing end. Another way to do it is you can also theoretically calculate the gravitational radiation by using Einstein's theory of relativity, such as how Taylor and Hulse did with their binary star system. And lastly is Weber's bar. Although unsuccessful, he attempted to detect gravity waves using his large aluminum bar, but it was never verified. One of the really cool parts of the LIGO detector is the dampening required for the mirrors at the end of each arm. Each mirror has a 4-stage pendulum that suppresses all outside vibrations near the detector arms. Anything from thunderstorms to passing cars to shifting of the seismic plates can cause interference in the detectors. Because of this, LIGO uses both passive and active dampening. The active part consists of 2 pendulums that contain seismometers. These are known as internal seismic isolation platforms, and they reduce the signal noise down to around 2 times 10 to the negative 13 meters. After the active part are 2 passive pendulums. They consist of silica threads, which are 400 microns thick. Silica does not expand or retract due to thermal changes, so it isolates for that as well. The final silica pendulum reduces the vibrations down to 10 to the negative 19 meters, which is required to be able to detect the gravitational waves. In Minecraft, a very crude replica of the LIGO detector can be made. Minecraft has a unique set of blocks called redstone, which can transmit signals that are sent through it, essentially like wires and electricity. In the detector, a signal is made by a redstone clock, which sends a continuous wave down each side. There are many types of clocks you can make in Minecraft. I just made 3 different types of hopper clocks that had different periods on their waves. The signal is then reflected up and then back, where a comparator compares the signals of both arms. It illuminates a light with the frequency of the wave. A longer or shorter pulse can be sent down each of the arms to simulate the stretching of spacetime, and the light will not light up, indicating a discrepancy between the two arms. Sadly, it's not able to graph the actual graph of the wave in Minecraft, but this is very similar to how the LIGO detector works.